Hello, today I'm finally back with another repair video, and this thing is a Mitsubishi receiver. I got this some while ago and I don't even remember the model number. It's probably written on the back here, but no matter. It looks like it's made, could have been made somewhere in the 80s, maybe early 90s. All I know is that it doesn't work, and I just put in two batteries in the remote here. I had to figure out how this all works here, and it's not that straightforward as I thought. So I'm going to go ahead and try to attempt to repair this thing. There's no schematic and there's no service manual, so I'm just going to have to go at it. So the first thing I'm going to do is take off the cover. So I got this thing open right now. We can see here the STK-4181. That's the amp section here. Looks like it's only got one here. It's got both channels. This IC is used for both channels, and there's nothing unusual in the unit itself. There's no funny smell, no missing parts, nothing burned. And over here I can see a row of fuses, 5 fuses. And when I just opened it up, I looked in there, those fuses seem to be good. And there's a relay, protection relay. So I'm going to go ahead and start this thing up. There's nothing more I can do. So take a look. Oh, okay, I see what the kind of unit this is. This is a DA-R47P receiver. Well, good. So I'm going to go ahead and slowly turn up the voltage. I have this unit hooked up to a variable isolation transformer, and slowly let's bring this thing up to line voltage and then see what happens. I'm just monitoring to make sure it doesn't draw too much current, and got something lighting up. Okay, now what else do I have to do to turn this thing on? It's just showing a display there. Huh, okay. We got the on button, that's on. What about this remote control-y thing? Okay, that's irritating loud. Wow. Let's see if I switch it like a radio function. What happens there? Okay, it's not drawing too much current, so we're okay. Huh, okay. Nothing happened. Nothing, well, nothing. I don't have any loudspeakers hooked up, so that part seems to be working. Okay. So let me go ahead now. I'm going to go ahead and turn the unit around and then check for DC output at the speakers. There shouldn't be very much there for both channels, the left channel and the right people. I'm going to do that next because I'm ventured to say this is another one of these dual supply units, and there's no output transformer. So let me go ahead and get the meter. So here we go. So again, the amp is directly coupled to the speaker, and it's a dual supply, meaning both positive and negative voltage are present, and so that means we should be getting 0 or close to 0 across the speakers here. Also, there's no output capacitor in the way, so let me go ahead and make sure I get good contact in here. Got these funky kind of I would say. This one's showing good. So try the next one out here. This one also. Gotta make sure I get it in there right. Oh, also, let me check before I go any further. Let me check if I even have the loudspeakers turned on. Back in a second. Okay, I did not have the loudspeakers turned on, and I've got them turned on here. You got to press the A loudspeakers or B loudspeakers, and you can see right here, 42 volts DC at the speaker output here, and that is no good at all. We don't want to hook up a loudspeaker to this. We don't want to put such a large voltage across the large DC voltage across the voice coil. Yep, that is the problem. Let me go to this side. Nope, where's the light here? Let me double check this one. Now, where was that? Swear to God, I was getting 42 volts a minute ago with this corny, there we go, with these corny loudspeaker terminals here. So that is the problem. I think I have a problem with the output IC. Let me go ahead and see how much one of these units costs, because this unit itself, if I can even get it, is only worth, well, probably only 20 bucks or something if you'd sell it. So I don't even know if it'd be worth my time. I might just end up parting it out. That'd probably be worth. It's got a nice size, look, a nice side heat sink in there, and a couple other things I can get out of there. So now, of course, I've got the power off, and I'm going to check the resistance between the, I'm going to start off by checking the resistance between the, here, the positive power supply and the outputs here. The outputs, I believe, are pin 10 and 13, and pin 11 is the supply. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's 1. That's between 10 and 11. And okay, now between 11 and 13. 13 is the output. Is the other output. It's the other channel. Okay, 0.5 ohms. So I needn't look no further. That seems to be the problem then. Let me go back to that other channel. So what I'm going to do now is, I guess, take it out and check a couple of components here in this area, and then I think that will probably be it. So now I decided to hook up a audio generator to this unit and feed in a sine wave through the aux input instead of unsoldering the whole thing. I was like, okay, what the hell, I'm just going to go ahead and try it out this way. So what I did is I unsoldered the output of the bad channel. I think thereafter it goes into the, some kind of protection circuitry, and then see if the other channel is working. You can see here the other channel is working just fine. So I'm not yet sure whether I'm going to continue on with this project. Either am I going to pull it apart for parts, or I'm going to go ahead and order a new IC. So I'm not going any further right now at this moment. Anyways, thanks for watching. In case I do decide to go the IC route and get another one, that's going to be I'm going to make a video out of that. I think also what I'm going to do right now, I'm going to go ahead in the bad channel here. I am going to check the components around here. Thanks for watching.